All right, today we're going to be talking about graphing a system of equations, all right? Now, a system of equations is dealing with how many lines? More than one. We're going to be dealing with 2 lines. Now, there are 3 things that can happen with 2 lines. What's happening with these 2 lines right there? They are doing what? They're crossing. What's another word for crossing? Intersecting. Wherever the 2 lines intersect, which in this particular case is that little tiny point right there, what's that referring to? That's referring to one solution. Okay? Now I'm going to skip this one, and I'm going to jump right over here to the parallel lines. Let's look at these parallel lines. If I have 2 lines that are parallel lines have the same what? Slope, right, they have the same slope. If these have the same slope, will they ever cross or intersect? No. That's why the answer is no solution. Okay? Now, the next one's kind of tricky because you're like, wait a second, why is that line thicker than the other ones? Well, what if you graphed one line, and then right on top of it, you graph that same line, that exact same line, twice? How many points do they share? All of them, right? So that's why it's called infinitely many. So imagine, like, they share every single point along the line. They share every single point, so it's infinitely many. Now there's some vocabulary words that you need to know. Intersecting lines are called consistent and independent. Infinitely many solutions are considered to be consistent and dependent, and parallel lines are considered to be inconsistent. So these are vocabulary. This is called terminology. These are vocabulary that you need to know that goes with these different scenarios. Okay? So what we're going to do right now, we're going to zoom out. Okay? We're going to look at problems 1, 2, 3, and 4. So I want you to, these are all the equations. Okay? So I'm going to highlight a couple of equations right now. We're going to highlight the first one in blue. The next one we're going to highlight in red. Okay? So here we go. The slope of this line. What's the slope of my first line? The slope is 1. And what's my y-intercept? -1. Okay? So if I wanted to find that line, I got to find the line that has a slope of 1 and a y-intercept of -1. Hey, there it is, right here. There's my slope of 1. What's my slope of this one? That's going to be a -1 slope. What's my y-intercept? A +1. Anybody see that line up there? There it is. Do those lines cross? Yeah, they do. Where do they cross? Right there. Does anybody know this ordered pair? From the origin, where do they cross? Right there. You're right. 1, 0. You're right. 1, 0. So how many solutions does this have? This has 1. So that's your answer for number 1. It has 1 solution. Okay? I'm going to go ahead and go to number 2. I'm going to do the same thing. I'm going to go blue and red. So let's find this line. X minus y equals -4. There it is, right here. They've labeled it for us, okay? Y equals x plus 4. Oh, that ends up becoming the exact same line. All right, I'm going to highlight what I'm talking about. Does everybody see x minus y equals -4 and y equals x plus 4? They're the exact same line. So what's my answer going to be for problem number 2? You're right. Say it again. Infinitely many. So that's your answer for number 2. Okay. Now what I'm going to do is I'm going to change colors real quick. Go back here. Go ahead and change colors for this one. I'm going to go green and orange. Okay. So right here, y equals x plus 4. There it is again. We just did that one. That has a slope of 1, and the y-intercept's at a 4. We're looking for what? 2x minus 2y equals 2. Right here. Oh, interesting. What do you notice about those 2 lines? Yeah, they're parallel, aren't they? They're parallel. How many solutions do they have? None, but no solutions. Okay, so that answer for that one is no solutions. Parallel lines have the same slope. Same slope. Okay. Since we're already done with that one, let's do two more. Okay, with these two lines right here. So we have y equals 2x minus 3. Got to find that. It's a steep slope. It's a slope of 2. A y-intercept at 3. There it is right there. That's a pretty steep slope. Okay? And then the other one is 2x minus 2. We just found that one. That's that orange line. I'm going to trace it with red. Does everybody see where those two intersect right in there? Okay. So what is the ordered pair from the origin? What's that ordered pair? How much do I have to go over and then up? You're right. Say it again. 2 and 1. Good. So do these intersect? They do. So we have, how many solutions do we have? We have one solution. And the solution is at a 2 and a 1. All right, so what we're going to do now, we're going to go ahead and zoom in on problem number 5 and take a nice long look at it. Okay? There we go, zooming out just a bit. There we go. Number 5. Now, by the way, this right here I'm going to be doing in blue. I'm going to make that a blue line. And this line right here I'm going to make a red line. Okay? Now, the blue line right here, that equation, does anybody know what form 2x minus y equals 1, what form that's considered to be in? I'll give you it. It's ax plus by equals c. You're right, it's standard form. Okay, it's standard form. Okay, that's standard form. Now, I don't want this in standard form. What I'd like it to be in, I want it to be in y equals mx plus b. So I want to change it to slope-intercept form. So I want to practice us changing that. That's something you need to know how to do by hand. Okay? So write this down right here in this column. All right? Now we're going to practice changing it into what? Slope-intercept form. All right, let's think about our very first step. Now there's multiple ways to do this. So if you do something that I may not do, you can still be correct. What would be the first thing that you guys would do to change it to slope-intercept form? Any volunteers? Everybody's nervous. Say it again. What do you want to go ahead? Minus 1 or add 1. Okay, so right now, what's our final form going to be? Y equals mx plus b. Okay, you can do that. Let's go ahead and do that. That'll work. Add y to this side. If I add y to this side, what do I have to do over here? I have to add a y to this side. Okay? So what does that leave me with? That leaves me with what? 2x. And what's that equal to? 1 plus y. So you can certainly do that. Now, is she almost done? She almost has y by itself, don't she? Not yet. Subtract 1. Here you go. Subtract 1 from this side and subtract 1 from this side. Now look what you have over here. What do you have? 2x minus 1 is equal to y. Those zeros out, those zero out. These are just 2x minus 1. So what's your final answer in slope-intercept form? Y equals 2x. So 2x minus 1 equals y is the same as y equals 2x minus 1. Now some of you might have said, you know what, that's not how I would have done it. Some of you might have done it this way. And some of you are like, that's not how I would have done it. So I'm going to do it the other way that some people probably would do it. Okay? Some people might go, I'm going to take away 2x from this side and take away 2x from this side. Now, what does that leave me with over here? That leaves me with a negative y equals negative 2x plus 1. So I'm going to move the negative 2x up front. Why is this way? You got to be careful. Because now what do I have? A negative, which means I need to either multiply or divide everything by a negative. And when I do that, a negative times a negative is a positive. A negative times a negative is a positive. A negative times a positive is a negative. And look what you end up getting. You get getting the same answer. What's our slope? Our slope is 2. Our y-intercept is negative 1. So we're going to go ahead and graph this line. Okay? So what's our y-intercept, everybody? Our y-intercept's at a negative 1. What's our slope? Up 2 over 1. Up 2 over 1. Up 2 over 1. But you can also go down 2 and over 1 to the left. Down 2 over 1 to the left. I want you to draw a nice line that goes through all of those points right there. All right, now this one, sometimes students get confused. How do we graph y equals -3? Now that has a slope, and it has a y-intercept. But the slope is 0, but the y-intercept's at a -3. So right here, at -3, put a point right there at -3. And then all you're going to do is draw a 0 slope. A 0 slope means it's a flat line that goes straight across. So what does that red line represent? That represents y equals -3. Does everybody see where those 2 points intersect? Those 2 points intersect where? At 1 point. What is the ordered pair that represents the solution to that point? How much do I have to go over? To the left? Yep, so -1, good. How much do I have to go down? How many units? Good, -3. We go down, 1, 2, 3. We go over 1 to the left, which is a -1, and down 3. This is your answer to number 5. That's your answer to number 5, okay? Now, did we use a graphing calculator at all on that one? No. So listen, let me show you how to do it in Desmos, okay? So in Desmos, this is all you would have to do. Okay, I'm going to go to Desmos. I'm going to clear some things out that we typed in from the last assignment. All I'm going to do is type in 2x minus y equals 1. Type in y equals -3. Okay, hit the home button. Can everybody see where the 2 lines intersect? Right there. Okay? Now, everybody, what I'd like you to be able to do is at least know how to find the ordered pairs that you need to plot. Okay? So, right here, what I'd like you to do is we need to change our steps to 1. On Desmos, change your step to 1. Okay? And that'll help you be able to graph it a little bit more accurately, where you can find points to plot. You guys see that right there? You can plot a what? A 1, and a 0, -1. So you can find points that you can plot on your paper. Okay? Now we're going to go ahead and use Desmos for number 6 to help you guys out. Okay, so let's go look at problem number 6. It says what? X equals 1, 2x plus y equals 4. So I'm going to go to Desmos right here to help you guys with the graphing. What was the first equation for problem number 6? X equals what? 1? Boom, there's x equals 1. All right? And then it's 2x plus y. What is it equal to? Equals 4? Okay. All right, there you go. Where's your solution? At a 1 and a 2. Now, how do you use Desmos to make sure you graph things accurately? Now, check this out. Okay? This one you can't really do, but go right here. Go to the second one. Okay, so we have this right here. What we're going to try to do is we're going to try to find a table. We need to get a table that goes with the point. I don't know if I can do a table. Maybe not. Maybe you can't do a table. All right, but we can zoom in. All right, does everybody see this point right there? I want you to plot a 1, 2, and I also want you to plot a what? 0, 4. So plot a 1, 2, and a 0, 4. We'll go over here to our assignment. Take a screenshot. The first one I'm going to do in blue. The next one I'm going to do in red. So here's the blue line. X equals 1. X equals 1 is a vertical line. The slope is undefinable, so it's undefined. Anytime it says x equals, what kind of line are you going to have? You're going to have a vertical line. If you don't know that, type it into Desmos. What were the ordered pairs I told you guys to plot? A 0 and a 4 and a what? 1 and a 2. What's my slope? Down 2 over 1. Down 2 over 1. Down 2 over 1. And that will allow you to graph the line. And what was our final answer for this? What's the ordered pair where the two lines cross? At a 1 and a 2. That is what's known as the solution. How would I change 2x plus y equals 4 into slope-intercept form? What's the only thing I would have to do to both sides? Take away a 2x. And there's your equation right there. What's your slope? -2. What's your y-intercept? +4. What's your slope do? Down 2 over 1. Down 2 over 1, down 2 over 1. And this right here, this is your solution. Alright, final problem right here. Here's your final problem. We're just going to do this by hand because it's really easy. So the blue line, I'm going to start. This is standard form. And over here, this is also standard form. What's the only thing that I have to do to change both of these to slope-intercept form, which is y equals mx plus b? What's the only thing I have to do? That's it. That's all you got to do. Good job. So all we have to do on both this one and this one is take away 3x from both sides. I'm going to take away 3x from this side, take away 3x from this side, take away 3x from this side, and take away 3x from this side. So my final answer for slope-intercept form is -3x plus 3. And what's this one over here? Y equals -3x minus 3. What do you guys notice about those lines? What do you notice about them? They're saying something. Saying what? Slope. Notice right up here. What does the m value represent in y equals mx plus b? It represents slope. What's this slope? -3. What's that slope? -3. What's the only difference? One of them has a y-intercept at +3. One of them has a y-intercept at -3. So we're going to go ahead and plot these out, okay? First one I'm going to do is blue. -1, -2, -3, put a point. Now, can I go down 3 and over 1 and still be on the page? Can I go down 3 and over 1? No, that puts me right here, right? So I can go up 3 and over 1 to the left. So go up 3 and over 1 to the left, up 3 and over 1 to the left, up 3 over 1 to the left. And now you have your points where you can draw a line. Very steep. Goes down 3 and over 1. The next one is similar. We're going to be at a +3 right here. We're going to go down 3 over 1, down 3 over 1. And you're going to draw a nice line going all the way down. Does everybody see how those are parallel lines? So what's our final answer going to be here? No solutions. Why is it no solutions? Because they do not cross anywhere. Okay? If they're the same line twice, that's when it's infinitely many. They're the exact same line twice. Alright? So if you struggle graphing them, what should you use? Desmos. Use Desmos and get your ordered pairs that you need to be able to do.